From our vantage point on Earth, the universe can seem like a vast and unchanging expanse. We gaze up at the stars, seemingly fixed in their constellations. We might assume that this cosmic tapestry has always been this way. But that would be wrong. The universe is a dynamic and ever-evolving place, and this is especially true when we consider the formation of planets. The story of how planets form is a tale of cosmic dust, gravity, and the relentless march of time. It is a story that takes us back to the very birth of our solar system and offers clues about the formation of countless planetary systems scattered across the universe. The process begins with a nebula, a vast cloud of gas and dust. These nebulae are the remnants of previous generations of stars that lived and died, scattering their enriched materials back into the cosmos. Within these stellar nurseries, the seeds of new stars and planetary systems are sown. Gravity, the architect of the universe, plays a pivotal role. It draws together the gas and dust within a nebula, causing it to collapse and spin. As the nebula collapses, it heats up, eventually reaching temperatures and pressures sufficient to ignite nuclear fusion at its core. A star is born. Nebulae, often described as clouds in space, are far more tenuous than any cloud on Earth. They are composed primarily of hydrogen and helium, the most abundant elements in the universe. However, they also contain trace amounts of heavier elements, the remnants of previous stellar explosions. These heavier elements, forged in the hearts of dying stars, are essential for the formation of planets and ultimately life itself. As a nebula collapses under its own gravity, it begins to spin faster and faster, much like a figure skater pulling in their arms. This spin causes the material to flatten into a disk around the newly forming star at the center. This disk, known as a protoplanetary disk, is where the magic of planet formation truly begins. The central region of the collapsing nebula continues to heat up, eventually reaching temperatures and pressures high enough to ignite nuclear fusion. The core bursts into life as a protostar, a young star still gathering mass from its surroundings. Within the swirling chaos of the protoplanetary disk, tiny dust grains, no larger than particles of smoke, are constantly colliding and sticking together. This process, known as accretion, is driven by electrostatic forces and the random motions of the particles themselves. Over thousands of years, these dust bunnies of the cosmos grow larger, forming pebble-sized objects, and eventually kilometer-sized bodies called planetesimals. As planetesimals grow larger, their gravitational pull increases. They begin to attract more and more dust and gas from the surrounding disk, further accelerating their growth. The inner regions of the protoplanetary disk are hotter than the outer regions due to the radiation from the newborn star. This temperature gradient plays a crucial role in determining the composition of the planets that will eventually form. Section 5. Solar winds and final orbits. As the central star ignites and enters its main sequence phase, it emits a powerful stream of charged particles known as the solar wind. This solar wind sweeps through the protoplanetary disk, clearing out any remaining gas and dust. The material that is not swept up by the forming planets is pushed outward, eventually dissipating into interstellar space. With the gas and dust cleared away, the planets settle into their final orbits. The inner solar system is dominated by the rocky terrestrial planets, while the outer solar system is home to the gas giants and ice giants. The asteroid belt, located between Mars and Jupiter, is thought to be a remnant of the early solar system, a collection of planetesimals that were prevented from forming a planet by the gravitational influence of Jupiter. Section 6. Conclusion, a cosmic ballet. The formation of planets is a complex and awe-inspiring process that spans millions of years. From the collapse of a nebula to the birth of a star and the subsequent formation of planets, it is a story of gravity, time, and the remarkable ability of matter to self-organize into complex structures. The next time you gaze up at the night sky, remember that those twinkling points of light are not just stars. They are also potential suns, orbited by their own families of planets, each with its own unique story to tell.